Today I'm going to talk to you about Tay Sachs and how it qualifies as a self-communication disease. So, cells communicate to each other through sending or receiving signals, whether that's within their environment or with each other. So the first step is reception. This is when a ligand is sent to a target cell. And then we go to transduction. This is when it's actually recepted and it morphs, and this change initiates the process of transduction. And then it is recepted and it responds and it activates the cellular response. And this is how our body functions and carries out processes. So Tay Sachs is an inherited disorder caused by a mutation of the hexagene, and the hexagene is responsible for making beta-hexacetamidase, which is an enzyme that breaks down GM2 ganglioside. This mutation occurs on chromosome 15, specifically 15q23 through q24. I have this right here where it specifically is. And this is an example of a normal GM2 metabolism. So this GM2 activator binds with this GM2 that picks up this lipid, phospholipid, from this chain. And then it comes down to here, and then this alpha and beta subunit bind together to make the hexacetamidase. And this is what breaks down this lipid. And it goes back up. So in Tay Sachs, they don't make the alpha subunit of beta-hexacetamidase. So this lipid cannot be broken down, so it builds up in the lysosomes of nerve cells. And this is an example of normal lysosomes. They have hardly anything in their residual vacuole. And then in Tay Sachs, they have a lot. So when they carry out exocytosis, they can't because of how much is built up in it. So symptoms of Tay Sachs, they usually have loss of motor skills, cataracts, hearing loss, muscle weakness, and cherry red spots in the eye. And what that is it's a indicator of GM2 buildup in your eye tissue. So upon eye exam, you can tell if someone has Tay Sachs. And then inheritance, it is autosomal recessive, so that means both parents have to be a carrier in order for your child to be affected. And it's a 1 in 4 chance, but anybody can get it. But it's mostly found in Ashkenazi Jews, French Canadians, Cajuns, and Amish. It's usually found in isolated communities or inbred communities. So, also I have statistics. 1 in 27 of Ashkenazi Jews, French Canadians, Cajuns, Amish people have it. In a regular general population, it's 1 in 250. So it's pretty big. It's pretty rare. This is my pedigree. As you can see, only the child with both recessive alleles is affected. So you can be a carrier and not be affected. Diagnosis. You can be diagnosed before birth by taking a sample of amniotic fluid when you're in utero, or you can have blood tests after you're born. Prevention. You can't prevent it, but you can have gene therapy to see if you are at risk or your child will be at risk if it runs in your family. And then treatment. There's no cure for Tay Sachs. However, it's mostly, the treatment consists of palliative care, and that's like just keeping the patient comfortable and helping with seizures or pain and their muscle weakness problems. There is research being done though with synthesized enzymes. They're trying to make it to where they could insert that enzyme in place of the beta-hexacetamidase to break that down, but they haven't figured out a way to insert it into your brain cells without all the other fluid getting in, according to ntsad.org. And then prognosis. There's 3 types of Tay Sachs. There's infantile, juvenile, and late onset, which is your adult years. Infantile is like 2 to 8 months, and then juvenile is like in your teen years. And then classic infantile, it's always fatal, and juvenile is also fatal. However, adult form, they say that they usually have like a normal lifespan because the GM2 accumulates over a longer period of time, so it doesn't affect them as much. Because in adult Tay Sachs, they do make the enzyme, but they don't make enough. And in infantile and juvenile, they don't make it at all. So it doesn't affect them as much as infantile and juvenile. This is my resources.